Why earthquakes occur near Burma, Myanmar, a geotectonic perspective. Earthquakes are sudden releases of energy in the Earth's crust, typically caused by the movement of tectonic plates. Some parts of the world experience frequent and severe earthquakes, while others remain relatively stable. The region around Burma, officially Myanmar, is one of the world's most active seismic zones. Earthquakes occur here regularly and sometimes with devastating consequences. The primary reason lies in Myanmar's unique geological location. It sits at the junction of three major tectonic plates: the Indian Plate, the Eurasian Plate, and the Sunda Plate. This triple junction, coupled with the presence of active fault lines and subduction zones, makes the region highly prone to earthquakes. This video explores the causes of earthquakes near Burma in detail, including tectonic setting, plate interactions, fault systems, historical earthquakes, and the implications for disaster management. 1. Tectonic setting of Burma. 1.1 Plate tectonics in Southeast Asia. The Earth's lithosphere is broken into tectonic plates that move slowly over the asthenosphere. Southeast Asia is one of the most complex tectonic environments in the world because several plates interact in close proximity. Burma is at the intersection of Indian Plate, moving northeast; Eurasian Plate, relatively stable; Sunda Plate, covering much of Southeast Asia. The motion of these plates relative to each other results in compression, collision, and strike, slip faulting, all of which generate earthquakes. Indian Plate movement. The Indian Plate moves northward at about 5 centimeters per year, colliding with the Eurasian Plate. This ongoing collision is what created the Himalayas to the north of Burma. However, because the Indian Plate does not just collide head-on but also slides obliquely, it exerts lateral stress on Burma's crust. The Burma microplate. Geologists identify a smaller tectonic block called the Burma microplate, which lies between the Indian and Sunda plates. This microplate accommodates stress by moving independently, leading to strike-slip faulting. The Sagaing fault, a major feature in Myanmar, runs along this microplate boundary. Major fault systems in Burma. The Sagaing fault. The Sagaing fault is a 1,200 km long right lateral strike-slip fault running through central Myanmar, from north to south. It is the most important earthquake-generating fault in the country. The fault accommodates the lateral motion between the Indian Plate and the Sunda Plate, moving about 18 to 20 mm per year. Earthquakes along the Sagaing fault can be very destructive, as they pass through densely populated areas including Mandalay and Yangon. Historical earthquakes along this fault have caused significant damage. The Indo-Burma subduction zone. To the west of Myanmar lies the Indo-Burma subduction zone, where the Indian Plate is subducting beneath the Burma microplate. This zone extends into the Bay of Bengal and the Andaman Sea. Subduction causes large megathrust earthquakes, which can also trigger tsunamis. The 2004 Indian Ocean earthquake and tsunami, although centered farther south near Sumatra, was related to the same tectonic boundary system. The Himalayan arc connection. To the north, the Indian Plate collides directly with the Eurasian Plate, uplifting the eastern Himalayas. Stress from this collision transmits southward into Burma, making northern Myanmar seismically active. Why earthquakes are frequent near Burma? Oblique convergence. The Indian Plate does not move directly northward but at an angle relative to the Eurasian and Sunda plates. This oblique convergence means part of the stress is absorbed as compression, causing mountain building, while another part is accommodated as lateral shear, causing strike-slip motion. This combination creates multiple earthquake-prone structures. Subduction and accretion. The Indo-Burma subduction zone is unusual because the Indian plate subducts at a shallow angle, creating an accretionary wedge. These sediments are prone to deformation, generating frequent shallow earthquakes. Shallow quakes tend to cause more damage at the surface. Crustal weakness and microplates. Because of the presence of the Burma microplate, stress is not distributed evenly. Instead, different blocks of the crust move at different speeds and directions, producing multiple fault systems and increasing seismic risk. Historical earthquakes in Burma. Myanmar has a long history of destructive earthquakes. Some notable examples: 1930 Pagu earthquake, magnitude 7.3, one of the deadliest, killed over 500 people. 1946 Sagaing earthquake, magnitude 7.3, caused widespread destruction in central Myanmar. 1956 Mandalay earthquake, significant structural damage reported. 2016 Chowk earthquake, magnitude 6.8, damaged historical temples in Bagan. 2021 Shan State earthquake, moderate but felt widely, showing continued activity. These events highlight the recurring risk in both central and northern Myanmar. Seismological studies. Geologists and seismologists have studied the Sagaing Fault and the Indo-Burma subduction zone extensively. Key findings. GPS measurements confirm that the Sagaing Fault slips at nearly 2 cm per year, accumulating stress that can be released in magnitude 7 plus earthquakes. The Indo-Burma wedge shows frequent interplate and intraplate earthquakes, meaning quakes can occur both at the plate boundary and within the crust itself. The presence of young sediments in the Irrawaddy Basin amplifies seismic waves, making ground shaking worse in populated valleys. Tsunami hazard connection. Because Burma is near a subduction zone, some earthquakes can trigger tsunamis. The 2004 Indian Ocean tsunami, which killed over 230,000 people across 14 countries, also affected Myanmar's coast. Although Burma was less affected than Indonesia, the event underscored the region's vulnerability. Any large subduction earthquake off the Rakhine coast could generate destructive tsunamis. Social and economic implications. Vulnerability of population. Myanmar is still developing, and many buildings are not earthquake resistant. Urban centers like Yangon and Mandalay have dense populations, increasing risk of casualties during strong earthquakes. Rural areas often rely on weakly constructed homes, which collapse easily. Infrastructure risk. Bridges, railways, and pipelines cross active fault zones. For example, parts of the China-Myanmar oil and gas pipeline run near seismically active areas. Disruption could have regional energy implications. Cultural heritage. Myanmar's famous temples in Bagan have suffered repeated damage from earthquakes, threatening irreplaceable cultural treasures. Preparedness and mitigation. Seismic monitoring. Myanmar has been working with international agencies to strengthen seismic monitoring networks. Real-time earthquake detection and early warning systems are limited but expanding. Building codes. Implementation of earthquake-resistant building codes remains uneven. Retrofitting older buildings and ensuring compliance for new construction are critical. Community awareness. Local communities need education on earthquake safety measures, evacuation drills, safe shelter identification, and awareness of secondary hazards like landslides and tsunamis. Regional cooperation. Because earthquakes and tsunamis affect multiple countries, regional cooperation, through ASEAN and Indian Ocean Tsunami Warning System, is vital. Scientific uncertainty and future outlook. Although scientists can identify fault systems and estimate recurrence intervals, predicting the exact time and place of an earthquake remains impossible. However, Studies suggest the sagaing fault is capable of producing magnitude 7 to 8 earthquakes every few hundred years. Stress accumulation in the Indo-Burma wedge indicates continued risk of major events. Urbanization without adequate preparedness could turn future earthquakes into humanitarian crises. Conclusion: earthquakes occur near Burma because of its location at the convergence of the Indian, Eurasian, and Sunda plates. The interaction of these plates creates major fault systems such as the Sagaing Fault and the Indo-Burma subduction zone. This unique tectonic environment produces frequent, often destructive earthquakes. Historical events demonstrate the persistent risk, while modern studies confirm ongoing stress accumulation. Given Myanmar's growing population, vulnerable infrastructure, and cultural heritage, the stakes are high. Preparedness through monitoring, building codes, awareness, and regional cooperation will be key to reducing future disaster impacts.